right, so language is everywhere. It's how we translate abstract thought into concrete terms, and it impacts every facet of our lives, academically, socially, and cognitively. So with that in mind, it's easy to imagine how variations in language ability result in varied qualities of life. One thing I learned in my child psychology class that really stuck with me is how this variation not only starts in childhood, but is most correlated to an external factor. That factor is something called socioeconomic status, abbreviated as SES. So SES is a measure of social standing that combines education, income, and occupation. So from this, I kind of started to reflect on my own position. As a college student getting to pursue higher education, I felt a sense of privilege. I'm lucky to be where I am, and my own SES background helped shape that. It just felt like an injustice that these kids born into a lower SES background were set back by something outside of their control. So, let's see, oh yeah. So I started reading more about these SES variations and initially came across a lot of articles that described a growing achievement gap between kids of high SES background versus kids of low socioeconomic background. And at this point, I was already working at the Brain Development Lab as a research assistant, and I was contributing to the Early Language Project, which was a large-scale study investigating the neural processing of language in children. So from there, the idea for my project just sort of clicked. What if I looked, oh, yeah, SES is also, sorry, the achievement gap is also something that has gotten a lot of interest from educators, policymakers, and even researchers. So again, back to my research project, the idea sort of clicked. What if I looked into the SES component of language development? So I thought if we could understand the neuroscience behind how these high SES kids versus these low SES kids process language, we can have more informed ways of closing the gap. So for this project, we defined SES by parental education, namely the mother's education, because it's closely related to home learning environment and was a stronger predictor of academic achievement than income and occupation. So the high SES group, the mothers had received at least a master's degree, and for the low SES group, the mothers had not completed college. And preliminary analysis of the MRI data, So for our study, we placed 5-year-old children in MRIs, and we decorate the MRIs like rocket ships to make it a little more fun for the kids. And you're probably familiar with MRIs at the doctor's office to look at different parts of your body. But in this case, it's used to examine the activation in your brain by looking at blood flow. So while the kids are in the MRI and it's scanning images of their brain, they play a word game. So they're presented 2 words auditorily, like dog and log, and then they determine whether those 2 words have any of the same sounds. So for dog and log, they rhyme, they would press yes. And they do this same sounds game because the ability to distinguish different sounds in words has been correlated to future reading ability. So preliminary analysis of the data shows that even if kids from high SES versus low SES are equal in language skill, they still use their brains differently. So to further explain that, here is a representation of 2 areas of the brain that were examined with this data. So the blue area is the area of the brain that processes sounds and words. And then we have this red area that processes meanings of words. And to break that down a little bit further, these graphs show the correlation between language skill, which is on the x-axis, and activation, which is on the y-axis. And so these 2 graphs are for specifically the blue region, which processes sounds. So for the high SES kids, there was a positive correlation. So as they got better at the same sounds game, they activated this region of the brain more, which processes sounds, so that makes sense. But for the low SES kids, there was no strong correlation. And then when we looked at the red area, which processes meaning, we saw that the high SES kids had a negative correlation. So as they improved in this game, they used this region of their brain less. And again, with the low SES kids, there was no strong correlation. So essentially what we can extrapolate from these results is that the high SES kids performed as we would expect neurologically. They were more specialized in their brain function, using the sound area of their brain more for the same sounds game, and the meaning area of their brain less. But the low SES kids, on the other hand, called on multiple representations of the words in order to complete the same sounds game. So they didn't just use the sound area of the brain, but they also used the meaning area of the brain. So, so regarding whether specialization impacts these kids, down the line. So at the age of 5, the specialization or lack thereof didn't really seem to have an effect in that they had similar performance levels. But the next step in this line of research would be to follow these kids longitudinally, which we are currently gathering data on, to see whether if specialization affects them further down the line.
Thank you.
So,